Concept for I think what I wanted to focus on was arrays for interviews. So just walking through everything you've done. How many of you actually have no idea what arrays are? I doubt anybody, right? Because you should know arrays is one of the fundamental data structures that we have. So what I'm curious to hear is when you're actually preparing for arrays, what are the key concepts that you should know that will help you do better in interviews? Like what are the things that you want to keep in mind?
Fixed in size.
Typically fixed in size, correct. Go on.
It can be accessed using DateX.
Direct access,
Direct
right?
access.
Go on.
Fast.
Fast for what?
If you want to access the random element.
Fast for access because you have direct access, and this applies to store and retrieve, right?
That's correct.
What is the big O for storage, and what's the big O for retrieval?
It's O1.
O1, right? O1 is because you don't actually spend any extra time. You just go straight to that thing, to the location. You can actually go replace and whatnot. What else?
Homogeneous.
Homogeneous, fantastic. What does homogeneous mean?
All the elements will be of the same type.
I don't know how to spell homogeneous, sorry. Okay? All the elements are of same type. Would it be okay if they are of like a parent type? Like, can I actually have a can I have an object array and can I have children based on that?
Yes.
So that is possible, but so the homogeneity is like kind of typically, right? Because you could potentially have class 1 and class 2 as long as the array is of the superclass or the parent class type. Makes sense? What else? Just grab a spot, please. What else? What is the first element of the array? Where is the first element of the array?
It is either 0 or 1 based. Most of the language is 0 based.
Okay. Most of the good languages are 0 based. You start with just one. Okay. All right. There are actually arrays where it is not 0 based, but it actually starts at some arbitrary constant as well. Very few times, and usually they are very specific languages. In most cases, you will essentially have it as either 0 based or 1 based. 0 based is typically more preferred, more commonly used. But anyway, what else?
The value type.
The data types are homogeneous. Is kind of what we are expecting, because we expect, though while we said they are homogeneous, there's one exception that we just talked about where they could be of different data types as long as the array itself is defined at a parent level at the same time. Right? It might be possible. What else?
Contiguous block of memory.
Contiguous block of memory. What does that mean? So fixed size, homogeneous data type, and contiguous block of memory.
So it's once it is assigned, it's the continuous block.
Contiguous block of memory in general, since it's fixed size, at the time of initializing the array, you dedicate a chunk of memory, and that chunk of memory is partitioned into n number of locations. Each location stores the array. So that's why that's why they're contiguous. The problem is that if an array can grow, then the contiguous block of memory is a little hard to allocate, because once you allocate one block, now if somebody gets the next block, how do I grow? Like, I can't, right? So the only way you can make that work, like array list, for example, actually gets around the problem. By how?
So, you said array list.
An array list.
Array list. Okay.
When they know the size, they allocate the new memory and copy all the members from.
Correct.
Very expensive.
So it's like, so what happens every time? Like, it's an array list is sort of a growable array. So it works like exactly like an array, but at some point of time when you're tipping the point between I'm out of space for the array, now I need to go bigger, what they do is that they allocate a new contiguous block of memory, replicate everything that you have into the new memory, and then they have like extra space to grow, and then they let go of the old memory essentially. I mean, a lot of this thing happens transparently behind the scenes, like you wouldn't know. But yes, arrays are typically contiguous blocks of memory. What about dimensionality? Like how many index elements can you actually provide in an array? Is it just one?
N number of. You can go.
So can I have? So you guys know what a one-dimensional is, right?
Yes.
What's a one-dimensional array? A typical array, A of I, and you're done, right? Can I have a 2D array?
Yes. Matrix.
Like a typical matrix. Okay, can I have a 3D array?
Yes.
4D, 5D, doesn't matter, like you can just keep going, it doesn't really matter.
No.
It's just a little harder for us to visualize beyond 3 dimensions, so otherwise there's nothing really stopping us from essentially having n-dimensional array. You can have 20, 30, doesn't matter. How is that possible? How are they actually making sure that you can do 2-dimensional arrays and 1-dimensional? How does it even work?
So when we say 2 by 2, they just allocate the block of memory of 4. But then when they translate it where that each block start, and when we say we are accessing element A to 1, so actually it goes and access the third from the beginning. So they all this arithmetic, but then it essentially gives the same characteristics of direct access and everything in that case.
So a 2-dimensional, let's talk specifically about a 2-dimensional array, right? So let us assume that I want to actually create a 2-dimensional array with 10 rows and 8 columns, okay? And I'm going to assume that it's a byte array. So how much memory should I allocate? Contiguous.
80.
So 80 bytes, right? So what I do is I allocate 80 bytes of memory, okay? So, and memory is, I want to address memory from 0. So I would go 0. What's the address of this location? Is 79. Okay. So now this element would essentially store a of 0, 0. Okay. And this element will store a of
7, 7.
Okay.
9,
7.
Okay. So far so good. Now what about the next element?
0, 1.
Is it 0, 1 or 1, 0? Does it matter?
I mean, it doesn't matter. I mean, if you are designing the language or compiler, you can have your. I mean, you can.
2-dimensional arrays, when you're actually representing it in terms of 1-dimensional contiguous memory, you essentially have this concept of like, is it stored row major or column major, right? So essentially, are you storing? So if I have this, right? So I have 10 rows and I have 8 columns. Essentially, this is the first row, second row, third row, and so on. So if I chop it by rows and say the first row is here, then the second row is just attached next to it, third row is attached next to it, that's essentially in the row major order. In which case, this will essentially be 0, 1, this will be 0, 2, and so on. I'll have 0, 7, and then followed by
1, 0.
1, 0, right? So that's how I'll do it. This is in the row major order. In the column major order, what you do is that you chop it up like columns, and then you store the first column essentially, and then you store the second column, and then you store the third column, and so on. When would you choose to do row major versus column major? And why? What's the point?
It depends on how you are going to access that data structure.
It depends on how you're going to access the data structure. Fantastic.
Yeah.
Yes, so typically all your design decisions, all your data choices, they're all entirely fueled by how you're going to consume it. What's the factor for me to, how do I store this information, how do I retrieve this information? If I am actually, so one of the things is that how does memory even work? What happens is you actually, in order for you need to change one element, right, you need to load the entire frame in memory, make a change, and then flush it back to disk. So if I'm making changes to 1, 2, 3, if I'm making changes to this, then this, and this in sequence more often than I'm trying to access something vertically or something like that, it makes sense for me to load the entire frame at one go and go. So it's just like there is a bunch of cache optimization. If you just purely look at, if each element simply means I'm going to load it to memory, change it, and then put it back to the disk, it wouldn't matter whether you store it in whichever order. But depending on how it's actually being used, it makes a huge difference. So fantastic. In the column major order, what happens is this is still 0, 0. What's the next one? 1, 0.
2, 0, 3, 0.
And so on. And what is the next one?
0, 1.
No, what's the last? So I would see 7, 0.
7.
What's next?
1, 1.
0, 1.
0.
No.
1, 1.
8, 0.
After 9.
Since it's different, right? Then 9, 0. The break is here. It becomes, this becomes 1, 0.
Yeah.
0, 1, sorry.
0, 1.
Yeah, right.
0, 1. Right? Column major, right? So the break is here. So essentially this guy broke here, this guy broke here. Okay? That's fine. It happens, and that's kind of what we need to keep in mind. Okay? So now, this is not just the only way of actually dealing with memory. With just this is because it's byte. What do you do if you have sub byte storage? How do you deal with things like a bit vector? A bit vector is not, it's actually the element that you're storing is not a byte. It's actually much less than a byte. So how do you deal with it? What is a bit vector?
So,
What is a bit vector?
Basically an array of bits.
Array of bits, array of booleans. Think of it as an array of booleans, right? So if I were to store an array of booleans, and let's assume that this was actually a bit vector, not a byte, right? Instead of byte, I say this is a bit. How much is the data space?
divided by 8.
It's less, but typically the operating system operate on the byte level.
Correct. So how much space do you want to store? How many bytes do you want to store in space?
10 bytes.
So it's just 10 bytes. Because it's 79 80 bits, so essentially equals 10 bytes. Right? Now if it's 10 bytes, how would you want to store it? Row major, column major? So in this case, it's actually kind of like sneaky because 8 bits is a byte, so,
Yeah.
well, you know what, it makes sense for me to mental model is think of each of them as just that, right? But nothing stops you from actually having like 8 of these, 2 of this, and then 6 of these, then 4 of this, and 4 of this, and so on. You can always like have it in a different way as well, right? So anything is possible when it comes to how you want to organize it, just because it's this way. So one of the computer games that I played like long ago is it's called Bricks, and what it does is that it actually uses, I believe, like a separate weird mode on the computer where it essentially has 50 lines. So normally your text is like 80 characters and 25 lines or something like that is what you have. So in this particular scenario, it actually has 50 lines, and on top of the 50 lines, and actually what it does is that it still has 80 characters only. But instead, what it does is that it actually uses the character of space. Then it has like there's a character which essentially has the left block alone set up, and then it has the character which has the full block set up. Okay. So what it does is that it actually uses. Actually, I don't think it even uses this. All it does is it doesn't use any of this. Sorry, it just uses this half block character, and it fills the entire screen with just half block characters. So what you're doing is it's just half blocks, half block, and so on. So this is the foreground color, and this is the background color. Foreground color and the background color, and so on. So for any character, you can set the foreground color and you can set the background color. So that's how it actually sets the pixel. If you set the foreground color to whatever, that's the left half. If you set the background color, that's the right half. And you could set whatever color you want with that. And the way they map that is they take that and they map it into an array, and then they actually essentially, how much space do you think is required to store this data structure? Like a screen where you have essentially 160 pixels horizontal, 50 pixels vertical, right? And each color can essentially be 0 to 15. How much space do you think is required? How many bytes do I need to store this?
80 by 50.
So
Go on.
each, when it is 0 to 15, so
4 bits.
that is 4 bits. Yeah.
Mhm.
So it's 160 into 50 divided by.
So how many screen dots do you have? Do you have 160 times 50 into 4 bits
divided
divided by 8 is
Yeah.
bytes.
Yeah.
Whatever the math actually works out to. Okay. So far so good. Okay. All right. So that takes care of most of this.
Delete is expensive.
Sorry again?
Delete is expensive. Like,
Yes.
That's one.
Yes. So what are the common operations you can perform in an array? So you can perform, what are the operations you perform in an array typically? So there is an initialize operation,
Add, remove, find.
init or create, which essentially allocates the memory, and that's not expensive, it's just a call, the system figures out where to give it from. Then you can actually set a value. Operation is big O of 1, we talked about that. Then it's like, get a particular value, we talked about that, it's also big O of 1. What about insert and delete? How can I insert an element and how can I delete an element?
Insert is basically you just go to the end of the
No,
last. I mean, you go to the last element and you add one more element after.
No,
that.
you.
No, that's not
no. You have to
insert
copy
is
the
like I want to
whole
add something between the 4th and the 5th element.
Yeah.
How do
Insert
you
is
do it?
expensive.
So you have to copy the whole array until the point, the first add into a new array, and you add a new element in that point, and copy the second half.
Copy everything else,
Yeah.
shift right, right?
Yeah.
To insert, and then shift left to
Left to
delete.
delete.
Uh-huh. What about how about insert in a two-dimensional array?
Very expensive.
It's the same because like, if you convert the two-dimensional array into the 1D array like what you did already, so we're still doing like you cut that one and shift.
Okay, how does insert work in a two-dimensional array? First, let's take a step back.
So we have to insert a full row or column.
Correct.
Yeah.
So how do I in a row major order, which is how they typically store it? If I want to insert a column, how do I do that?
So you have basically.
Let folks take a second to visualize. In a row major order, if I have an array set up, all I'm looking for is I'm trying to find a way to insert. Does not mean that you're actually growing. Insert simply means that you're just moving the elements out. So let's assume that the last column was like nothing, was blank or can be deleted. So when I insert in the second column, all I'm saying is all data of second column is moved to third column, all data of third column is moved to fourth column, and so on.
Right.
And all the data in the seventh column, which is like the seventh index, is ejected. Right? I'm not even looking at it. So that essentially creates a void here, which I can fill it up with later. So that's kind of what I want to do. Like imagine it's like an Excel row insert that we do, a column insert that we do. Let's think of it that way. So if I were to do that, how does it work in a fixed mode?
You have to go through each row, and you have to shift those like elements where you want to insert. You have to shift all those elements in each row to the right, and then you have the space. So you go through the row, all the rows again, and put your new.
So you have to go to each
rows.
But it's a contiguous array thing, right? So if I need to insert, so for example, I'm inserting in a second row, right?
Mm-hmm.
So I need to essentially move all these elements, like
To the right.
to the actually including the 2, right? I need to move all of these elements here,
Yes.
and I need to discard this element, right? On the same way, I need to take I need to keep this element as is.
Yeah.
I need to move all these elements, right, to this location,
That's
and I need to discard this.
That's correct.
And I need to keep repeating this like 10 times. That needs to happen. Not an easy-ish operation, because it's like you need to make sure, think through how this actually will work. Okay, so there's a little bit more to think about how that works. So insert is expensive in one dimension, like 1D arrays are the easy things to figure out. In 2-dimensional array, you're just repeating the same operation multiple times. What if I have to insert a row?
Again, it depends where,
Uh,
it still has to move.
Insert a row in row major would be a little bit easy. Basically, you.
Inserting a row is very easy, because insert columns, I had to do like a boatload of stuff. But inserting a row is essentially what I do is I figure out this is like row 0, this is my row 1, this is my row 2, and I have the rest of the rows. If I have to insert something after row 2, all I have to do is essentially copy all these elements up to whatever the 9th row, and essentially copy that over in one block. Because there's none of this magic stuff is required. Like you don't have to keep going at different rows, because that's how the memory is organized. So depending on what your actual use case is, like inserting a row in this particular data structure is much simpler, because it's just one mass copy operation, right? So that takes care of insert. That takes care of delete. What else? What else is good about array? What else is different about array? What else is difficult? What happens when you can I have negative indices of an array?
No.
Why not? What if I need it?
We need to create some mapping that the negative would map to some positive values.
Right. So one of the things is that if we talk about here, right, very rarely the operating system or the language that we're looking at actually has capability to support like arbitrary indices, like start off. Like certain languages will let you define arrays like that. But essentially all it is nothing more than a convenience function, which is just the offset. Right? All you're doing is every call to like a 7 is essentially translated to, okay, I start at -3, so 7 is actually the 11th element, and I'm just going to go +4 and things like that. So that's what it's doing for all of those elements. Oh, +3, right? So 10. So it goes from 0 to 10, right? So that's kind of how this thing gets mapped. So typically you don't have negative indices, because that's kind of how you define your array. What happens if you go beyond the size of the array in general?
I mean, it depends on the language.
Most commonly, what happens?
Exception, area with the bounds exception.
In
Index
Java,
by
it will
found,
go
area,
sometimes,
like in the illegal access or something like that in many cases. Or in some languages, it doesn't care. It just gives you whatever the data is there.
Like
C.
C doesn't care.
There's no concept of that, right? It's just like, the boundaries are not enforced. So it'll give you whatever data is there. Here, take it, and then you can do whatever you want to do with it. Okay? So make sense? So anything else, any other concept that I think is important in array? So definitely make sure that you're checking for bounds in your interviews. Knowing these basic concepts help. Now there's a slight angle to this, which is essentially strings are very similar to arrays. Why? Many questions that are string-oriented Java questions or interview questions can actually be applied with arrays. And very array-oriented questions can be sort of, managed with strings as well. Because what is a string?
So most
Character.
of the
Character.
character of arrays. So
Okay.
all the array
In most cases, there are exceptions like this now. Character array, array of characters. So it's like a string. A string is nothing but just contiguous characters of that's just strung together into a text, right? So what is the? Let me just draw a few lists. Have you heard of ASCII Z or null terminated string?
Yeah, the last character is no, 0.
Yes. So typically, what happens is in a string or a text is supposed to have you don't know what the length is. So it doesn't make sense for you to keep initializing that space over and over again, or keep initializing the string and things like that. In order for you to provide for a string, what we do is that we allocate as much as we think is necessary, and then the string essentially contains a boatload of characters terminated with a 0. So if you want to say hello, you would essentially say hello and a 0. And most the languages automatically take care of it. So when you assign the string, it automatically adds a null termination to it, and so on. So for how many bytes do you think that takes? Hello?
6.
6. Because it's like the hello is 5, 2, 3, 4, 5, and the 0 is the 1, which is essentially 6. So it takes 6. Length is 6. Right? Even though the length of the thing is 5, the size that it takes in memory is 6. Certain languages, like Pascal, actually what happens is that the first character essentially stores the length. And then the remaining characters essentially store the actual characters. So hello would be stored as a character of 5, and then HELLO. It's still 6 in terms of space. What's the limitation for this structure?
What is the biggest length of the string?
255. You can't store any string longer than 255 in Pascal. So there's the inherent limitation of the string length in Pascal is 255. Why? Is because it actually is a length-based system. Okay. What's the if I were to pick between these two options, which one would you pick and why? What's the length of any given string?
Could be anything. So I'd rather choose null termination because you can have any length of string. I like it.
But if I'm doing length-based operations always, I'm trying to figure out if length of A is greater than length of B.
Right.
What's the big O of determining length in the ASCII Z format and the length format in this format?
That's going to be ON+1.
Then Pascal is better because
Of course, right? Because it's right there.
It's right.
But what is the limitation?
255.
No more than 255 characters. And
How
ASCII
does
Z
it compute
is.
the length in the first place?
So again,
How does it compute the length in the first place?
whenever you store the data itself contains length and the data.
No,
So
but how does it know the length? We should have done something to know the length, right?
how do you initialize the object in the first place? When you initialize the object, you have to populate every element, and that takes you go through n bytes. At that time, it actually stores the value as self right at the top of it. So you still have to go through all the characters, but once it's done, the entire data entity itself contains length plus a bunch of characters. So it's sort of like the length computation is faster. It's a hack because of course it's going to be faster because it's length based, right? But it comes with its own limitations. So that's what it is. Limitation. The other challenge, of course, is in ASCII Z is that if you actually accidentally overrun the 0, what happens? If you do not allocate adequate space, or if something happens and the 0 just drops off for whatever reason, null terminated string actually will return. It will throw a bunch of garbage that it encounters another 0 somewhere, right? So that's strings for you. So now, just like we talked about this, can we have double dimension strings? Of course, we can have single dimension strings, but can we have double dimension strings?
Array of strings.
That's what you want.
An array of string is in like if I have to store a crossword puzzle, for example, or like the word finder matrix, right? Would you store that as an array of strings, or would you store that as a arrays characters? What would make more sense for you?
Character.
Okay, array of characters makes more sense. Like array or like a double dimensional array of characters makes more sense. What's the difference between a two-dimensional array and an array of array?
It's almost same.
Almost, but then what's the difference?
Array of arrays.
Or the data
Oh.
type.
Mm-hmm.
I think array of array is like each character, each index have a different size, have different array. I mean a different size at each index, so it's not in the same size.
Mm-hmm.
So two-dimensional arrays mean like we have,
Mm-hmm.
for example, 3, 4. Yeah, but with the array of array, like each of them like at the next one you can have like an array of size 2.
Like it doesn't need to be like continuous memory for
Yeah,
each
that's
array.
true.
Yeah, something like that.
Okay, so we all know what a two-dimensional array is. We just walked through some parts of it. We kind of know what array of array is. What's the difference? So I heard one was, I think she said the same thing as well, is that two-dimensional array, if you visually look at it, each column has to have the same length. You can have multiple rows, but they'll all be the same length. Whereas in the array of array scenario, it could be
Staggered.
Yeah, something like that.
could be fun. Right?
Yep.
Why?
Because you can individually allocate each array in the array.
Mhm.
Yeah.
So what's the time complexity of locating an element in a two-dimensional array?
It's 2 by length into
Oh, I mean-
row into
You're
one.
mathematically
one.
figuring out and then
One.
you're finding the element.
Row
It's
into
of
one.
one, right?
One.
Big of one.
It's big of one.
Oh,
To
you
locate
said
an
finding, right?
To locate an element.
Look, okay.
So
Yeah, it's
if
one.
I'll tell you, get me the 5th row, 7th column, right? Of one, because you can mathematically figure it out. What about here?
Same idea.
Oh, man, no.
Because
It's gonna be
No.
you just need to go to that memory address and offset.
So what you need to do is you need to
It's
go
like ON.
figure out.
Figure out what the index is.
Each array.
Essentially, what this is that it's just each of these things are just these are all individual arrays. So this array just maps the starting location of each of the arrays. That's it. So essentially, what happens is that you need to do a first lookup of this, and then a lookup of that.
This
So
is
you need to
one.
look up the 10th array, and then you need to look up the 7th column, in that like 7th element in the 10th array, and that's about it. So it is 2 lookups versus it's just 1 lookup, but they go,
Actually,
they
it's
go
the
off
same.
one. Alright? So given like a crossword structure, would you choose array of arrays or 2D arrays? Not crossword, word finder, word jumble.
2D because it's like fixed kind of thing. Like it's a usually it looks like a square, so you can block certain
Like
characters.
Sudoku, for example, right? Sudoku is an example. If I were to like do Sudoku, would you do 2 dimensional or would you do array of
For
arrays?
Sudoku 2 dimensional.
2 dimensional.
Pretty much guaranteed, most folks who actually code it up would probably use array of arrays. Because in your mind, if you actually allocate array of arrays of the same column length, it looks the same, it doesn't matter, there's no practical difference, big O doesn't change, and and some languages don't even support multi-dimensional arrays the same way. So here it will essentially be something like this, and in this case it will be something like that, right? A row, comma, column, or whatever you want to do. So the definition changes because essentially it's a one-dimensional array, and then each dimension stores another array, and that's what you get here. Can I have different data types in these rows?
No.
Yes.
Can I store different data types?
Each row different data types?
Uh-huh.
No, because then you have to define that
Yeah.
first array of the what type you are going to
Yeah.
store. So
Mhm.
it would be same actually.
Yeah.
So the thing is that here each element has to be homogeneous, has to be the same data type, with the only exception is that you could have different elements, they have the same parent class,
Same family.
and you could just have the array of the parent and then all child classes are permitted.
Mhm.
In this particular scenario, what happens?
Same.
Is it the same or is it subtle difference? There's a subtle difference. The subtle difference is
Row.
that each of these things, right, they follow the same property.
Mm.
Okay, and this guy follows the same property.
Yeah.
So which theoretically means that you could have the master class, the column wise, you could essentially store array of numbers in here in this case, and then in the column wise you can actually say this could be an array of ints, where int is a subclass of number. So there are different ways by which. So then what happens is that the data type of the adjacent elements, they are not tightly linked together with the data type of the element stored in the array that defines the array. There's a little bit of difference. This actually offers a lot more restrictions than this.
Yeah, but I think language will only let you define only one type, right? For any language supposed to support days. When you define the variable, you can't say that each row is a different. I mean, you have to always say base type.
Each row is different because each row is the object of a specific type. So if I can have array of numbers. So essentially this array of numbers is what this is. Whereas when I store the object, I could be storing an array of int and an array of double or something like that.
But that can be true for the same for this also.
Not at a row level.
Because I can have a
not at a row level. There is no enforcement at a row level. It is for the entire array because it's a two-dimensional array.
Oh, so you're saying that here there will be enforcement.
This will be enforced, right? I can actually create, because if I create this entire row array, if I create the row array of type whatever, int, or if I create it of type double, then I can only use doubles in that particular row.
I thought that subclassing happen at the element level and not the whole array.
You can do it at the whole array level as well, because an array of ints is, I think, a subclass of array of numbers. Okay. I could store an array of numbers into array of int. I believe I can, but fair enough. So ignore if that is not true, but essentially all I'm saying is that structurally it's a little different. Why would you do this versus this? When would you actually pick an array over two-dimensional array?
When each row has a different number of elements.
Easy, because that's one benefit. The other option is that if your operating system actually stores, or if your language and a compiler actually stores something in column major order, and you need row major order, then you can actually enforce row majority by that. Or the other way around. If you can, this actually gives you an enforcement of you're going this way first and this way next, right? Otherwise, in this particular option, you don't really know. It depends on what the compiler chooses internally in terms of however it compiles and whatnot. So this gives you a little bit more control over how you're actually trying to get to the elements. Minor stuff. All right. So now that we have spent a lot of time on arrays, right? Now let's actually try to see if we can use some of these concepts for an interview question. So what array interview questions have folks actually recently faced? Let's start with that, and then otherwise we'll start with the question that we have prepared. Give me what kind of questions you guys have prepared for, which have been asked in interviews or you're working on, which are array based.
I just have a very basic.
Oh, go ahead.
I missed out one. So in Java, for example, when you create, int of, and then you put two brackets. So is that array of arrays, or is it 2D arrays? How do we differentiate in the way we create it?
How do you distinguish between how do you distinguish between a two-dimensional? How do you initialize a two-dimensional array in Java versus an array of arrays?
Because I used to think that the latter is two-dimensional array when I say int of two brackets and then new int of say 6, 6, 8.
Can you say that again, please?
The way you are initializing it, like
what's the difference in declaration for
it's a
How do you-
array,
Yeah, how do you?
and an array is like if you use it's like array of array.
Oh, I see. That's the
Yeah, array list. Yeah, right.
array list is what is called array of array. Okay.
Yeah.
Right. So you write this way.
Right.
Two-dimensional.
What does it initialize?
This is two-dimensional.
This is two-dimensional, correct?
Okay.
Yeah.
Is there a way for me to do this? I don't know how do you initialize an array of just an array without any length in Java?
Just int, and the
No,
first
you
one
need to
gives the
specify the
length
length.
and other give
You use like array list or
You
something.
need to use array list.
Yeah.
Otherwise, you
Yes,
can specify the
7,
length.
6, 7.
I think defining would be difficult, but if you initialize it with some value, there you can give the different length of values for
So can I actually do that?
Yeah, and give the different length of
Probably.
Can I do this?
Not for an array.
Can I do that in Java?
It is a
Yeah, you can. So you can
So what is the length of the first array?
I see. Okay.
What's the length of the second array? So second array, second row, 3. So it's essentially creating this. So this, to me, actually from what I understand, is actually still an array of arrays, except that it's just convenience function which initializes everything of length 9. I don't think that creates a two-dimensional array, not in the strictest sense of the thing. Even if I were to look at the memory allocation for this, I don't think it will be contiguous.
I see.
Because theoretically later you could actually say something like this, right?
What is it?
Something like that. And then you're just like assigning over the array, which is like if you had a similar definition for j, you could just swap in one row of I into a row of j, just like that. And since you're able to access and independently manipulate each element, you should be able to, I think it just still creates a two-dimensional array. It's just a convenience function. It doesn't create a 2D array.
Okay.
It creates an array of arrays.
So how do you create a 2D array?
I don't think Java lets you create 2D arrays.
On the first one,
No, the
wait,
first
yeah,
one
yeah.
is a
The
2D
first
array.
one is two-dimensional.
I think it's a convenience function which just creates an array of the same column length, I think.
Internally.
Because it lets you do this afterwards. Even if you did this, right? If I did this and I did j was the same thing, I could do this. Just like take 7th element of j and then like copy over into the first element of 7 is this. I have to put it as a number, but sure.
I tried if you remove the 9 is a defined array of array. Like if the 9 you leave it at the
Correct.
blank.
So it's just creating. It's just a matter of creation. So if you just do that, then I'm assuming it's just creating an array of.
That's the array of
The,
array.
what you can do is you can create an array of object, and then in a loop you can assign each element to an array. That's how you basically create an array of array in Java.
And I think this also does the same thing. I don't think the concept of two-dimensional arrays actually exists in Java the same way it exists in C.
Okay.
At least to my understanding. I don't know. I'll have to read through that a little bit more to see what does. Alright?
I'm going to
Thanks for the question. Very helpful.
So one final question. Confirmation. AOA is like they are not contiguous. It's individual, like in a row. Second row.
Array of arrays. Is the memory allocation for array of arrays contiguous?
Each array would be contiguous. So
So each
whole
of
row
these
will be
elements will
contiguous.
be contiguous.
Yeah.
And then this need not be contiguous with just. I mean,
Right.
it may be, maybe not. When you're asking for arrays, it may be contiguous, it may be not.
Right.
But there's no
It's an
requirement.
array.
So-
It's an array itself, so that will also be contiguous in that
So
sense.
just
The entire.
perfect.
Yeah.
Right.
That's not true, because what happens is that when there's an array of arrays, what it does is that it creates an array of just locations of where the array is. It's more like pointers or
Pointers,
reference
Yeah.
to the other array. So the references are contiguous. The reference for the
Yeah.
first element is adjacent to the reference of second element, is adjacent to the reference of third element. But the location of where the first element is, the first array is not necessarily adjacent to where the second array is. That makes sense?
So you're saying two-dimensional array in terms of everything being like a
It will be the
actual
180
square.
characters,
Oh,
the
okay.
80 bytes will be contiguous.
So in Java that will never happen. That will never happen then.
This
In
should,
Java is
I
always-
don't think there's a way to initialize this in Java. Somebody prove me wrong, and maybe I need to learn how to do that. Maybe there's a way for me to specify
Or
that.
is it
Because
because
in
they're primitive
certain
data?
languages, it lets you do A of I comma j, this sort of a comma mechanism where the comma is inside in the index itself. That represents a multi-dimensional system. And sometimes it actually individually addressable elements, where you can address each row independently. So that's how it works. So I believe Java is always in this particular pattern. Even if you initialize the values upfront, it's just a convenience function of actually creating 9 arrays or 7 arrays of size 9, and that's about it. So I don't think I don't think it's actually creating a contiguous block of 63 elements. It's actually creating 7 arrays of 9 elements each, and they may not be contiguous. Okay.
So a follow-up question. Like,
Go ahead.
we did agree that like it's individual. Like the array are like not non-contiguous. It's going to be in any place in the
It could be
memory.
anywhere in the memory.
So that means like that implies that in memory-intensive applications where you're assigning and releasing the memory time and again, it's always better to use duty over AOA because the memory manager is gonna have to work. There will be an overlay to the memory manager to free the array over to the array. Do we agree with that?
In the
'Cause it
2D
has
array
to go-
scenario, you're just asking for one chunk
of memory. Go ahead,
of
delete it.
memory, which is
Right.
of in this example 63
Right.
bytes,
Right.
In the other scenario, it's actually
Memory manager
asking
has to
for
do-
7 times. It's
Seven
actually
times,
making the
exactly.
request for 9 chunks. So
Exactly
that
right.
it depends. Sometimes
Okay,
this is more efficient because it's actually easier to find smaller bits of memory.
Right.
It's very hard to find 63 consecutive bits of bytes of memory maybe.
When they assign it, I'm talking about when they delete it. When they free it, AOA has an overhead over 2D most of the time.
Line types or like row types
Row
has
types,
many
right,
as
exactly, right.
Absolutely.
Great,
But
thanks.
it's more memory efficient in that sense where it can actually make use of smaller bits of smaller fragments of memory.
So 2D arrays in which language? are 2D
Usually
arrays?
I've seen 2D arrays used in both like basic, Pascal, Java, in C++, C,
Okay.
assembly language. I mean, those are all the places where I've seen these things used. And in some scenarios, what you can also do is that you can logically construct a two-dimensional array structure. Like you can actually, define. For example, if you're defining like an image in memory, like a GIF or a BMP or something, you would load the entire file in memory, and then that's like just an array stream or like a byte stream. And then in that byte stream, if you want to index it, you would actually take as functions x and y, and then you can also do the two-dimensional array computation. So understand the logic so that you can actually use it and implement it. Make sense? Alright? Okay. So let's